Okay, okay. Can people hear? No. Okay, right. So this is very strange. So I am not used to this. However, hopefully the stream should be kind of working. I'm going to open YouTube on my phone so that I can read chat whilst programming. Oh, it seems to be working. Okay. Oh, it seems to be working. There's a big stream delay. Okay. Okay. Anyway, I can read chat now. So basically, the point of this live stream is to be able to okay. So basically, we're building a text editor, but not just any text editor. We're going to edit code rather than text, which is kind of a strange idea, right? Like, obviously, normal text editors like, I don't know, Vim or VS Code. Like, obviously, you're editing code, but the way you do it is very different. So the point of Sapling as a text editor is that if you instead of inputting text into a buffer to say, oh, I'm going to write some code. So for example, in Vim, if I edit some of the code, then I will be just typing code into typing text into the buffer, like some function, and that will be how you write code. But the thing is, you're just typing text. I could just spam a load of keys, and that's okay. But the thing is, if I save this is completely invalid Rust code, and if I try to build it, then it will just completely fail. So the idea behind Sapling is that instead of writing text to build some code, you instead directly edit the code. Oh no, lol. Okay, is this better? That there's enormous stream delay, so it will be about 20 seconds before anything happens. Okay, so let's start all that again. So basically, so I'm here in Vim editing some Rust code. It's the main function of Sapling, but for illustration. So the kind of editing model that everyone is used to is the whole like edit text, you write text into a buffer, and that's okay. But that's kind of less than ideal, because when I think, oh, I'd like to create a function called foo, all I'm thinking is I want to create a function called foo, but in order to do that, I have to press a load of keys. I have to write fun foo, put some brackets, and then open and close brackets, and that's a lot of effort, and it doesn't match with what I'm thinking. So the idea behind Sapling is that you should be able to, the editor should understand what the code is. The code is a load of functions and then some code inside it, for example. And so you should be able to just select like the root of the code. So you select the entire file, and then in one shortcut, you should be able to put insert a function. Whatever that may be, it might be like I for insert, then F, for example. So currently, Sapling doesn't work very well. Cargo run. It kind of works. So we have some JSON here, which is about the simplest language I could think of. It's essentially just you have objects and arrays, and in this case, I've just limited it to true and false as the values you can use, which is very basic. And at the moment, there's not much point using Sapling, right? So, yeah. However, what we can do is, if you look at the code, you'll see that rather than having a cursor in the text like we have in Vim that we can move around, we instead have selected the root element. And it turns out moving a cursor through a syntax tree is incredibly difficult in Rust because of the way it handles memory. But what we can do is we can do things like replace the root node. So for example, I want to replace the root node with true. So we can type R for replace and then T for true. And then the whole tree disappears and you only end up with true. We can undo that. And we could replace it with anything. We could replace it with an object, with RO, and then with an array, which is probably quite difficult to see. Can we? Okay, we can't zoom in right now, it seems. And then, or we can replace it with false. And that's currently kind of the state of Sapling right now. Except obviously a lot of stuff has to go in internally to make that work. So can we, we can make it bigger. Is the code the right size, by the way? I can make it bigger. Fun stream delay. We'll get to wait a whole load of time. Okay, good. Oh, hey Marcus. So okay, we can make Vim bigger as well. The thing is, I have very long lines of code, so I didn't want everything to line wrap. Is this good? Fun stream delay. Okay, I'll wait for replies. For the time being, I think what I should probably do. Cool. Right. So what I think we should do, since this is the first stream, what I think it would be good is to just explain how Sapling works and internally, that is, how it tries to achieve the syntax tree editing. And so I will hopefully, if OBS behaves itself, I should be able to switch to, no, not that. I should be able to switch to this. Hopefully that's worked. And so I've got a picture that I can draw on. Hold on, let me move it so I can see chat at the same time. So essentially inside Sapling, all of the code is just it is just a tree. So for example, in JSON, we could have, oh, this is very small. Okay. Oh, gotta love GIMP's editing skills, editing text. Okay, so we could have something like this, which is true, false, and it's a bracket. And this is 3 lines of text and maybe lots of characters. But ideally, what that actually represents is you have an object which, so at the root of the tree, oh my, drawing with just a mouse is so hard. Okay, so you have an object, which I'm just going to write like this. And then inside it, it has 2 children. It has true, which I'll just call T, and false. And let's suppose, so internally inside Sapling will only store this tree. It won't actually store any text. And so whenever it needs to display any code to the screen, it figures out where all of the pieces of code are going to end up and prints them all to the screen. At the moment, it just randomly assigns every node in the tree a different color, so I can kind of debug what's going on. And so how you would edit this is you would have a node selected. So let's say I have this one selected. So I'm selecting the root. And then I should be able to perform actions on the tree. So you would have like editing mode, like the way Vim does. You would do something like hit I, and then so you'd like hit I, and then I don't know, you want to insert false into the array. So then you'd hit IF. Let's get that right. Okay, so you'd hit IF, and then Sapling would insert another false. So the list now contains true, false, false. And then Sapling won't even touch any text at this point. It will just change the syntax tree in memory. And then it will try and render to the screen once you've done that action so that you get some feedback. And then it will go, aha, well, the new code is true, false, true. It might pretty print it, so true will be on a new line like this. But it really doesn't matter how Sapling is rendering to the screen. It's just because you're a programmer and you need to see it as text. You can't really be expected to write code directly as a syntax tree. Particularly as syntax trees are very inefficient with their screen space. So yeah, and now let's say I wanted to replace this F that I just added. I didn't mean to insert false. I wanted to insert an object. So I would somehow move the cursor down to here. So now we've got, now we rub this out very badly, and then move the cursor. Let's just scribble that out a bit more. So we'd move the cursor down to the false, and then we'd press, I don't know, R with RO for replace false with an object. And then false would get removed and replaced with an empty object. Oh, so okay, so I realized that pretend these are all lists, because you can't actually just put these into a JSON object. And then you could carry on editing and add more false, true, false, or whatever. And so you could build up the code that way. And then whenever you save to a file, Sapling will figure out what the text has to be. And then by doing that, hopefully, if this idea even scales to bigger projects, but to bigger languages like, say, Rust, which has a huge amount of complexity in what you're allowed to do, then editing code will just be, you think about how the code should change, and then you press keys to do it. and that would be how you would edit text. And I think that would probably be faster on the basis that it's just a kind of step up from modal editing already. That the way Vim works, you have yeah. Hold on, I'll switch over to the IDE view, which is broken again. What fun. Is that it? No, it's this one. Okay. Right, we have the right Windows pack. So this is just a step for those who might be watching this in the future, who haven't used Vim before. Vim by default, you press keys and they don't go into the buffer. So for example, I could press D right now, and then D appears in the corner of my screen down here, and nothing happens. And in fact, what Vim is waiting for is another instruction, because D means delete. And so it will wait for me to do something else, like press D again, which D twice means delete a line. So doing that will delete the line. But notice, so in a normal text editor like VS Code, I would have to do that by deleting 2 characters. Or even worse, like deleting a line like this, I can do it in 2 characters with Vim, whereas I would have to get my mouse, do a selection, and then press delete, which won't work on a terminal. But you get the idea. So the next kind of step up is that you would select this whole code block, because it is just one code element. It takes up, what's this, 5 or 6 lines, but it is in fact only one code block. And therefore it would be nice if you could think about that as one unit and delete it all at the same time, which at the moment it's probably possible with Vim to do it fairly quickly, but it wouldn't be as easy as selecting everything in one shot as one code element in the syntax tree and then deleting with D. So that's the idea behind Sapling. It's just a giant experiment. I have no idea. I have no idea how it might work, if it does work at all. It might just be incredibly difficult to learn, in which case we'll have to find a way of making it easier. But for the time being, I don't know. No one knows if it's going to work until we have a prototype. So that's what I was doing. And I figured I'd stream the process, because why not, right? Like, it seemed like an interesting thing to try out. And this whole project is just an experiment anyway, so why not add a bit more experimentation? Oh, thanks. How many... Oh, did you come from Reddit, I guess? Arvinder. Or... Anyway, I have at least 3 viewers now. This is cool. Or in fact, I have 3 concurrent views. Excellent. So I kind of have 2 ideas for what we could do with this stream, because currently the logging on Sapling is kind of interesting, because ideally you just print to the console, but obviously the entire terminal is oh cool, nice. I'm glad someone found my post on Reddit and wasn't like, hey, that guy is just cheekily plugging his stream. But we can't... Okay, so what was I doing before my brain ran out of steam? Okay, yeah, so the logging currently logs in this column, in this area, because you can't print to a terminal if you're using the entire terminal for editing text. So what I was hoping to do would be to make some kind of client-server thing that you can use Sapling. So Sapling can just send HTTP requests to a server that then prints them. because that doesn't require any state, so you don't need to do stuff. Or I could attempt to get the cursor moving working, which is going to be quite interesting because Rust really doesn't like the way I've currently implemented it. We could just implement it from scratch. What do you guys think? I'll wait for the responses to come through. Got a lot of stream delay. I'll have a drink as well. Okay. So I think we should do the attempt to do the cursor movement. Least of all because I think it would be a good excuse to go through most of the code at the moment, so that you can kind of follow what I'm doing. There's currently a bug in the terminal thing. The terminal library I'm using, which means it doesn't return a cursor to you. So I just have to open Vim and close it again, and now I get a cursor. Fun bugs. I don't know why that's happening. So pretty much the code for Sapling is broken up into some chunks. So you have just the root directory. We have main, which is the main function, which gets run. And all that really does a small amount of initialization and then passes control into the editor function, so it creates a new editor structure and then passes control to that. And then the editor handles user input, printing to the terminal, that kind of thing. Then internally, we have some kind of way of representing syntax trees. And this is kind of broken into two pieces, which is probably not a great idea, but the whole thing's an experiment. So I was just did the first thing that came into my mind. So we have some way of specifying a syntax tree, which is essentially, that's a giant trait. If we move into this and look at mod.rs, then this is just a big trait that's called AST spec. And it needs a reference type, which is essentially what does it look like to have a reference to a child node. Because ideally, storing syntax trees as a recursive data type is all very well, but I feel like it would be faster to store it differently. So that's why this reference type is here. And it has a load of things like what's the size on the screen of a given node. For example, writing all of the text to the screen is specified here. But this syntax tree specification doesn't really, ideally, it shouldn't really care how the nodes are actually being put in memory, because that leaves the editor up to deciding where to put everything, making sure that everything is fast. Thinking about it, if you guys have any questions as I'm going along, or I do something silly, which I'm guaranteed to do, just stick it in chat, and then about 20 seconds later I'll pick it up. I think that would probably be good to say. Also, I'm not sure how long I'll be streaming for, because I'm pretty new to this, and streaming is going to be quite tiring, I reckon. So maybe I'll probably stop, I don't know, at 7 or 7:30. Depends if we're likely to get something done. So pretty much the whole of the AST folder AST spec folder. This entire folder is different ways of representing syntax trees and a load of utility structures to go along with it. And then we have editable tree, which is, it kind of builds on a syntax tree, like AST spec. It takes a syntax tree specification and it adds things like undo. It allows you to do stuff like replace nodes easily. So that will turn into just a function call. So if we look at editable tree, then there's a big trait here with a load of functions like undo, redo, get me, like a function to say where is the cursor, and what node is underneath the cursor. And then we've got all of the edit methods here. So we've got replace cursor, which whatever code is handling the editable tree gives it a new node, and then the editable tree manages the fact that as a new change, whatever node is under the cursor will be replaced by that. And it's up to the editable tree implementation to say, oh, hold on, if you undo, then we need to revert the tree back to an earlier stage. So it needs to have some kind of ability to undo. We also have insert child. I'm not sure how that's going to work for things like, because it's not clear, you could want to insert a tree of things into it, in which case just inserting a node won't cut it. And then we've got the display methods, which the editor needs to run, which is that you need to be able to write text to the screen. And then we need to be able to render text. So this is just the write string takes a string reference and then builds, writes the content to that string, so that Sapling doesn't have to continually allocate memory, which is inefficient. And then toText is the sort of like a version that just returns a string, right? So it takes a format, some kind of instruction for how to format the tree, and then returns a string with it. And this just calls write text here. So then moving up, this is all of the kind of the ways that trees can be modified. But what we need is a way to store the nodes in memory, because we didn't care how that was done, but we still need some kind of, we still need something to do that. So that's handled in Nodemap as well. Oh, this looks terrible. We'll need to zoom out a bit. Can everyone still see the thing? Just shout if it's too small. So the Nodemap just has, Nodemap is essentially a mapping from some kind of reference type to nodes which have that reference type as its children, right? So you can, reference types in most cases, this ref will just be an integer, so it will index into a list of nodes. And then the nodes, instead of just leaving pointers hanging around, they say, oh, my first child is node number 1, and then it's up to the node map to say, oh, that node number 1, that is in fact using get node, we take a reference, and then that is this node. And so this might fail. You could just arbitrarily create a reference that's out of date, or it was just created with unsafe code or something. We'd quite like to avoid being able to just randomly create these, because they should be references and they should be guaranteed to exist. Maybe it will be easier just to keep these reference as just pure pointers into the into some kind of table, and then we need to know. Okay, so I've picked up the Temporal Dragons thing about the stream. So we're looking at how this is fairly implementation detail stuff. We're looking at how nodes will be stored in, so how the trees will be stored in memory, essentially. And then we have a mutable version. So to quickly recap, we have traits that's Nodemap, which is like an immutable node map. You can get a node with this function. We can get the root of the tree, and we can get the root as a node. And this could fail. So if the whatever reference the root is doesn't exist, then you can't get the root node, and doing so will currently crash the code, crash Sapling, which is much less than ideal for a production text editor. But for an editor that's just an experiment, we don't need to be able to do that. These are more just like specifications. On their own, they can't do anything. So where do we go now? So we've done everything except what's in editor. Editor is kind of the interesting stuff, which is we have all this stuff is logging. So how you logged to the screen. Sorry, how the logging system currently works, which I just threw in here because I didn't know what else to do. And now we have a big enum, which is for Temporal Dragon, who hasn't done Rust, or other people who haven't done any Rust code. An enum is of a data type that can take lots of different values. So an action is either undefined, which basically means the user typed a string of characters that doesn't correspond to a command. Or it's an instruction to say quit Sapling, or it's going to be replace the current node with a node that's referred to by this character. Because programming languages are complicated. You can't really expect one set of key bindings to work for all of them. So my idea was that we have language-specific key bindings. And then we can insert a child, very similar to the first. You specify a character along with that to say, oh yeah, we're going to insert, I don't know, in the case of JSON, like true or false, or an object, what are we going to insert? And then we have undo and redo. And this will be expanded as the feature set of Sapling grows. And scrolling down, we have a function that parses a string of text into code. So it takes a string, which is what the user has typed, and then if it is a valid action, then it will return the action. Otherwise, it won't. And the editor structure holds all of the top level stuff. So it holds what the state of the tree is at this time, a small buffer which is written to when the user types characters, and whenever that corresponds to a valid command, that command is executed and the buffer is reset to nothing. And it has a terminal, which is what we're printing to, and then the style of the tree at this moment is there. And then there's some logging stuff that I hope to remove. And then we have a load of editor-specific stuff. So this will be functions like, replace the cursor with stuff, insert a child, undo, redo. Mostly this is just forwarding on to the editable tree, which handles all of this stuff at a lower level. But this also logs what's going on so that I can see. Then we need to be able to render and then update the display. And then in here, we have a big main loop as well, and then some tests. So I'm yeah, that's basically an overview of the code. I hope that's not too like in detail. I'm not sure what is needed, but if I fly around the code now, then there should be some idea of what is happening. Is everyone cool with that? If I've gone too fast or this doesn't make any sense, which it might not, it could easily not make sense, just shout in the chat and I'll go over things. So what should we do? So if we... Nice, cool. So what I think we should attempt to do at the moment is to implement some kind of cursor, because at the moment all of the instructions say we want to replace with true. They always apply to the root, which is kind of silly. Sapling always initializes with some nice JSON, which I just added there in the code. But now we're essentially limited to having 4 different things. We can either have an object as the top level, or we can have an array as the top level, or we have false, or we have true. Okay, and that's kind of, that's not a code editor, right? So what we'd ideally like to do, if we undo all the way back, we'd ideally like to be able to move the cursor down. So we'd have some kind of keyboard shortcut that would move the cursor from highlighting just the root node, which in this case is a list of things. We'd want to move it down to, say, true. So down as in down the tree. Because if I switch to the illustration, the tree currently consists of something like, if I add another layer, oh no, we need a white layer. Okay, so the tree currently corresponds to an array at the top level, and then it has 3 children. So it has 2 true, it has false as another child, and then it has an object, which, and the way it's implemented currently is that the object, oh wait, you guys won't be able to see this, hold on, let me just write the text in here. So the code is true, false, value, true. Okay. So we've got this is the text that will be displayed to us, but that's not what Sapling is visualizing. Sapling sees this tree, which we're still completing. Inside, so we've got this object, we've got true and false, and then we've got some kind of object in here, which is going to be some pair of value as a string. Oh. Typing with drawing with a mouse is incredibly hard. I have value, and as the value that this field takes, it's true. Pardon the childish drawings, but I haven't had to draw with a mouse this much before. So ideally what we do, we can only modify this node in the tree, which is essentially we replace the entire tree with something, either true or any other thing. But what we'd really like to be able to do is to somehow move this pointer to somewhere else in the tree. So we need a way in the code to store a cursor, which currently it doesn't exist because the cursor is kind of fixed to the root of the tree. But we can't, we can't use just a pointer into the tree, because what I'd quite like to be able to do is that if we have two nodes, like we have true twice, it's kind of silly to hold the variable, to hold two different copies of whatever the value of true is. That doesn't really make very much sense, because we could just hold one, and then we'd end up with one value, and instead of having this, we'd instead have another pointer over to here. So true. So the real issue with this is that, let's say we have our cursor points to true, and then we try and move up the tree. So we're saying, oh, I'm too far down the tree, like I'm inside some expression somewhere, and I need to get back up. But what is that? Like, which value of true are you talking about? Because there are currently two. There's this one, and then there's this one. And they're both true, and they are both in memory exactly the same. So in order to qualify that, we need to store some kind of path down the tree. So we say, if we were referring to the true that was here, so we're referring to this true, for example, then we would store, instead of just a pointer to that, we would store, okay, well, the root of the base of the path is this node, and let's get red text. Come on, I need red. Okay, so the first element is here. So the path starts nowhere, goes to the root, because the tree always starts in the root, and it says, okay, follow this link down, and then this link down. And that's how you get to true. So now, moving up the tree, now we know it must be this one, because we've gone to true, then we've gone down to this open bracket. Yes, so it would make more sense. So I've just seen would it makes more sense to have a dictionary of values? Yes, it would. The way the Rust compiler works, it sort of has a very fancy dictionary of values. It has a big, what's essentially a vector of values, and then that stores all of the nodes. And then in order to do it, you just have, in the Rust compiler, you just pass around references into this potentially huge list of everything that the compiler's seen so far, which is called an arena allocator. And that's probably the strategy that Sapling will do. I like the dictionary of values thing. For the time being, since I feel like it's writing a production editor that's super experimental is not really going to work. Like that's really kind of doomed to failure. So it would probably, like, we don't need the slight increase in speed that the Rust compiler has gone for. We just want to have something that we can kind of get a feel for, right? So let's see. Let's switch back to some code. So let's say. So I don't think we have time tonight to completely rewrite how nodes are stored. But what we can do is we can, so that the cursor path idea doesn't care about whether or not it's a dictionary or a vector or whatever. It just cares about the fact that it's a path of a tree. In fact, would it make more sense to implement the dictionary of values approach? So because that won't take, like, I don't know how long implementing the cursor will take. So Or we could just end the stream here because I'm quite tired and hungry. I'm in the UK, so it's like nearly 7, and I haven't eaten since lunch. I don't know. I feel like that might be a bit of a like anticlimax to the end of the stream. What do you guys think? I'm sorry for the like wait. This is going to end up. I feel like you're all going to reply, and then I'm just going to wait a while for me to see your replies. I feel like there must be a better way of doing this, but I haven't done any streaming before. Okay, I think so. What we could do, I'm not super convinced that the current architecture is good, because I was writing... Oh, cool. So I think I'll call it here. What I think for next week, what I think we should do next is perhaps it would be a good idea just to start from scratch and kind of rebuild everything without an idea for performance, because the whole idea of having a node map and having a syntax tree specification that doesn't care about how things are stored, that's all very that's very performance focused. It makes the code massively more complicated, and the only advantage you really get is speed. But I feel like rewriting it might potentially be better for the streams as well, because then it won't be like I'm editing a code base that I've done a lot of work on and you guys have never seen before. I don't know, what do you guys think? Just as for what we do next week. another wait. I need to figure out what to do about this stream delay. Other people must have a way around it. Cool. Okay. That's a point, actually. To be fair, it's been a few weeks since, more than a few weeks. It's been like a month since I've seen the source code as well. So I'm not particularly familiar with it. I could get more familiar with it during the week, but I feel like in not knowing how the project is, because it's such an experiment, right? I think I've kind of gone down a rabbit hole that we could probably start again and go down a different strategy. So either way, we're going to be trying to implement a cursor setup next week, I think. Does that sound like a good plan? Okay. Stream delay is a great thing. It's pretty weird. Okay, cool. I mean, so yeah, thank you all for. Oh yes, I am the boss. I guess. So, I mean, thank you all for turning up and watching me be a new streamer. It means a lot to have people turn up. And we'll find something to do next time, I'm sure. It won't be Halloween. Happy Halloween, everybody. But I feel like this has been a fairly decent first stream, I guess. So I think I'm going to call it there. Now, how does one stop a stream?